Okay, you guys did pretty good on your quiz yesterday. Some of you are still struggling a little bit with your factoring. And you need to factor to do what we're doing the next couple days here, finding common denominators and multiplying. Put that down, Caleb. Thank you. All right, so today and tomorrow we're adding and subtracting these rational fractions, these rational functions. All right, rational means a fraction. In order to add or subtract fractions, you got to have a common denominator, right? So once you have a common denominator, all you do is add the numerators. Okay, that's what this is saying in the key idea. You don't add the denominators. Got that? You don't add the denominators. The denominator stays the same. You just add the numerators. You guys should know that from elementary school, right? So let's remember that. So what's this answer? Very good. 10 over 4x. 7 plus 3. Now, can you simplify that though? Yeah. What goes into 10 and 4? 2. So we should make that 5 over 2x. Okay? Because 2 goes into 4 twice. And 2 goes into 10 5 times, right? Okay, so we're still simplifying just like we did yesterday on our quiz. All right. Now, I don't know if they're going to tell us to find the restrictions on the denominator, but what's x not allowed to be? 0, right? 2 times what or 4 times what is 0? 0, right? When it's multiplication, x cannot be 0 then. Got a common denominator then, right? So, what's 2x minus 5 equal? Are they like terms? No. So it's just 2x minus 5, right? Yeah. So it's 2x minus 5x, then it's negative 3x, right? So those aren't like terms, so you just write 2x minus 5 over x plus 6, right? Can you factor top or bottom? No. So you're finished. You can't simplify it. Right, Emma? What's x not allowed to be? Negative 6, right? Just like on the quiz. So those are real easy when they already have, excuse me, already have a common denominator, right? Just add the numerators. The hard part for kids is finding the common denominator, all right? So that's what we're going to show you now. All right? I can't add these until I get a common denominator. And all they're basically doing is multiplying those two together, right? And then once you get the common denominator, you can add the numerators or subtract the numerators, depending what you're supposed to do. Right, so it says you can always find a common denominator of rational expressions by multiplying the denominators as shown above. However, when you use the least common denominator, or the least common multiple, then you can simplify your answers taking fewer steps, that's all. It says to find the least common multiple or least common denominator, factor the expressions completely, and then the least common multiple or denominator, we're just going to call it denominator. All right. Factor expressions completing. It's the product, meaning multiplication, of the highest power of each factor that appears in either of the expressions. Okay? So whatever, here's what I'm going to tell you. Once you have a factor, whatever shows up, you write it down. Okay, Caitlin? And if it shows up more than once, you don't have to write it down more than once. But if you have exponents, you write the higher exponent. Okay? So let's see what that looks like. Can I factor 9x squared? there any pluses or minuses with it? No, so I can't factor it. What about the 3x squared plus 3x?
Yeah.
Yes, you can, right? Take out the GCF. Okay? I mean, you could factor this if you wanted this to 3 squared times x squared. Okay? If you wanted to. All right? So, what shows up? I see a 3. I see an x. I see another 3, another x. Do I have to write it again? If it shows up, you write it down, but you don't have to write it down multiple times. And what else do you see? An x plus 1, right? Look at exponents. Do any of these have exponents? Yeah, you put the higher exponent. What's higher, 1 or 2? 2. So that's my common denominator, or my least common denominator, actually. Right, Wolf? All right, so what I would do is write this as 9x squared and x plus 1. All right, so I'm going to rewrite this problem with the common denominator, which we just figured out. Okay? So, here's what you do again. You factor what you can. Whatever factor shows up, you write it down. It only has to show up once. It doesn't have to show up in both. And then any exponents, you write the higher exponent down. That becomes your least common denominator. Okay? Any questions so far? Okay. Look at the original denominator. Look at our new denominator. What's different? So what do I have to multiply the 7 by? X plus 1. Whatever I did to the original denominator, I also have to do to the original numerator. Okay? So this would be 7 times x plus 1 instead of just the 7. Okay? So here's the original. Okay? What's different here?
It's got to be squared.
Right? I multiplied the 3 by what to get 9? 3, right?
Oh, please. That's fun.
I multiplied x by x. And there's an x there, so that's, all right? So the x was already there. I multiplied the bottom by a 3 and an x. So I had a 3 in front, and then x times x is x squared, and the x plus 1 was already there, right? So there's my second numerator now. Okay? There was a 3. Now it's a 9, so I multiplied by 3. So I multiplied the numerator by 3. All right? There's an x. It's x squared right here. So I multiplied to get x squared. I multiplied by an x. So I multiplied that x by x. That's how that x squared came to be. Already had the x plus 1, so that's nothing new, right? Whatever I did to the bottom, I do to the top. Now I can add them. Before I add, though, I have to do what? What's this? Distribute. That's multiplication, right? Do multiplication before addition, right? So we got to distribute that. So that's a 7x plus 7. So combine like terms. Are there any like terms? No. So you just write all 3 of them out. So 3x squared plus 7x plus plus 7 is my numerator. And then 9x squared and x plus 1 is my denominator. Now, we're supposed to see if we can simplify that, just like we did before on yesterday's quiz. Number 5, you had to simplify a fraction, right? So, the bottom is already factored, okay? But the top, we might be able to factor. Okay, we've done one here in the last week where we had to do this. What's 3 times 7?
21.
21, right? Are there factors of 21 that add up to 7? Well, we got 1 and 21 or 3 and 7. Do either one of those add up to 7? No. So is it factorable? No. Okay.
What?
Okay, so that's our answer. Now, what is x not allowed to be?
-1.
-1, 0. Good. Questions? First time we do this, kids get a little bit confused, right? So let me go through the steps again. Factor both denominators. Whatever factor shows up, you write it down. So a 3 showed up, an x showed up. I don't have to write it again when it shows up again. And then x plus 1 showed up. We look at exponents. Well, we had a 3 squared and an x squared, so we have to use the higher exponent. That's how we got the 9x squared. 3 squared was the 9. Okay? Then you look at what the original denominator was and your common denominator, and whatever you did to the original denominator, you also have to do to the original numerator. That's what we did. Any multiplication you do before you do addition or subtraction then. Combine like terms, get it to one fraction, and then try to simplify the fraction like we've done in the last week and this week. Okay? So it takes a while, but once you get the hang of it, it's not so bad. All right, let's look at another one. Okay, so can't really factor that. I mean, if you want, you can write 3 times x, but really 3 times x squared is all you can do. Is there a GCF here? 3, right? So then you get 3x squared minus 4, right? That's all you can do, right?
Yeah.
All right, so what shows up? 3, an x squared, what else? 3x squared minus 4, right? Don't have to write that extra 3 down again. So I rewrite the two fractions with the common denominator. So look at the original denominator. What did I do to it to get the common denominator? What did we multiply by? Yeah. 3x squared minus 4, didn't we? Here's the original. Here's the new one. What did we do to it? We multiplied by this, right?
Yeah.
So what's 1 times that?
Itself.
Here's the original. Once it's factored, what did we do to it? The x squared, right? You guys see that? We multiplied by x squared. So what's x times x squared? X cubed. All right?
So do you have to like separate the 3x squared, or can you just?
No, you can leave it as 3x squared.
Okay, so that's just an extra step. You just have to factor like.
The 9x squared minus 12. Yeah. All right. So what's this answer? What's the numerator? Combine like terms.
3x or 9x to 1.
Oops, not 9. Okay. Let me see if the book worries about the zeros for the denominator. I didn't check that. I should have. Yeah, they're not really asking for that, so we're not going to worry about that. Questions? This, you guys done talking about it? This is not factorable. Okay? No GCF. There's no way to get x cubed, 3x squared. If there was an x in here somewhere, you might be able to do it, but it's not going to work out. All right? So far, so good? Any questions? Any questions about how we got these numerators? Okay, let's do another one. Let's go to subtraction. All right. What can I do to factor this? Pull out the 2, right? What's 2x divided by 2? X. What's negative 2 divided by 2? We good? Are there factors of 3 that add up to negative 4? Yeah, what are they? Negative 1 and negative 3, right? Remember, some tricks here you guys might have forgot. Let me remind you. When the C value, the 3, here is positive, when you factor it, they're both whatever's in front of the B, this minus sign. That's why these are both minus. If that was a plus 4, these would have been plus 1 and plus 3. Okay? Whenever that third term is positive. Whenever that third term is negative, then we got a positive and negative in there. Okay? Something to remember. All right. So what shows up? You got to write down everything that shows up. What do you guys see over here? A 2. What else? Minus 1 and a minus 3. Right? So whatever shows up, you write down. Are there any exponents I got to worry about? No. But if there were, do I use the smaller or the larger exponent? Larger. Very good. You guys are listening. Okay. So, here's the original first denominator. Here's our common denominator. What did we do to it? Multiplied by what? X minus 3. So I have to multiply the x plus 2 by x minus 3. Okay. Here's the original second denominator. Here's our common denominator. What do we do to it? Multiplied by 2, right? So I got to multiply this by 2. Questions? Right.
Why would you multiply it by two?
Okay, so here's the original. See both of those? What did I do to it? I multiplied by 2, right?
Yeah.
So whatever I did to this, I gotta do to that. So I can multiply that by 2.
Why don't you do it on the other?
Okay, here was the original, which is these two. What did I multiply by? X minus 3. So I had to multiply the top by x minus 3. So whatever I do to the bottom, I also have to do to the top when I rewrite my fractions with the common denominator. Okay? Any other questions? So now I have to do multiplication before I do this subtraction, right? Well, how do I multiply those? What's it called? FOIL, right? So I'm going to FOIL them. X squared for first, outside negative 3x, inside positive 2x, last negative 6. How do I multiply these? Just distribute. So negative 4x and a negative 2. You with me there? Now that I've done that multiplication, I'll subtract them. All right, so my bottom doesn't change. Once I get the common denominator, I leave it, right? So, x squared minus no other x squareds is x squared. What's a negative 3x plus 2x? Negative 1x minus a negative 4x. Negative 1 minus a negative 4.
Or positive.
Positive 3, right? Minus a negative is what? Addition, right? So it's negative 1 plus 4, which is 3x. What's negative 6 minus negative 2? So it's negative 6 plus 2, right? Because it's minus a negative 2. What's negative 6 plus 2? Negative 4. All right. Are there factors of negative 4 that add up to positive 3? See if I can simplify.
4 negative 1.
Yeah, 4 negative 1. So, I'll do it in green. This factors in the positive 4, x plus 4, sorry, and x minus 1. Do you see any factors that are the same, like we had yesterday?
Negative 1, negative 1.
Yeah, the x minus 1s, right? So, those will cancel. So, my final answer, top is x plus 4. And bottom is the 2 and the x minus 3. So there's our final answer to that subtraction problem. It's not that hard. It does take some time, yes. Once you get the hang of the procedure, it's the same every time. Just remember, minus a negative is addition, right? So that's where we tend to get tripped up. We do everything right, and then we do minus a negative, and we still subtract instead of add. Okay? Questions on that example? All right, let's do one more, because I think we need to practice.
That's okay. That's okay with me.
All right? So, factor the first denominator. What can you factor out of there? It will factor.
Negative, negative, negative.
Yeah. They're both negative. Why?
Because it's an add.
It's addition there, so they're both that. And what are the factors of 2? 1 and 2, right? Negative 1 times negative 2 is positive 2. Negative 1 plus negative 2 is negative 3, right? What can I factor here? A 2, right? And what's 2x divided by 2? What's negative 4 divided by 2? So what's shows up? I see an x minus 1, an x minus 2, and a 2, right? So you write all those down. Whatever shows up, you write them down, right, Boyard? Right, Emma? Are there any exponents I gotta worry about? No. If there were, which one would I use, Sydney? Bigger. Sydney's, voice got really low there for a second. Okay, so look here. This is the original first denominator. What do we do to this to get this?
Multiply by 2.
Right, so I gotta multiply the top by the 2. We okay with that? Here's the second denominator. What did we multiply by? The x minus 1. You see that? So it's negative 2x minus 1 times x minus 1. Questions? No one? You get that? Good. So, what do I do with the 2? Distribute. Very good. 2 times 5x. 2 times negative 1. How do I multiply those? FOIL it, right? Let's FOIL it. First, outside, inside, last, right? So, negative 2x squared plus 1x plus 1, right? When I combine like terms there? Now, let's finish it up. I'm just going to bring it over here so I got more room. That doesn't change. All right, combining like terms. There's no x squareds here. So 0x squared minus a negative 2x squared is positive 2x squared. 10x minus 1x is 9x. Negative 2 minus 1 is negative 3, right? All right. Let me check this. If I multiply 2 times negative 3, are there factors of negative 6 that add up to positive 9? No. So there's my answer. Is this making sense to you?
Good.
So remember, the first couple we did already had a common denominator, right? So all we have to do is add the numerators, keep the denominator the same. The last few, we had to turn it into a common denominator problem, right? Okay. Hey, good job paying attention. Most of us. Like Doodle Wolf. You soaking in? Factoring's important still for this section.
He's giggling during the imagine.